most people focus on the two-dimensional surface that we have here on Earth, disputes about financial matters, Brexit. When you look at the big picture, these are childish issues.
Hi, I'm Ian Bremmer, and welcome to the GZERO World Podcast, an audio version of what you can find on public television, where I analyze global topics, sit down with big guests, and make use of small puppets. This week, I sit down with Harvard Astrophysicist Avi Loeb to examine cutting-edge research on the galaxies, everything from interstellar travel to black holes. Let's get to it.
The GZERO World is brought to you by our founding sponsor, First Republic. First Republic, a private bank and wealth management company. Imagine a bank without teller lines, where your banker knows your name and its most prized currency is extraordinary client service. Hear directly from First Republic's clients by visiting firstrepublic.com.
Avi Loeb, professor, director of the astronomy department here at Harvard, founder of the Black Hole Institute. Welcome to the program.
Thank you for having me.
We've been sort of submerged into this first photograph that everyone has now seen, which you said was not all that surprising.
It wasn't surprising because a decade ago, we wrote a paper with my postdoctoral fellow, Avery Broderick, in which we predicted how the image would look like. That was the first paper that drew attention to M87, this giant galaxy that is much bigger than the Milky Way galaxy, at a distance that is 2,000 times farther than the distance to the center of our galaxy. But because it has a black hole that is 6.5 billion times the mass of the sun, that is about 1,600 times more massive than the black hole in the Milky Way galaxy, it's so big on the sky that we can actually resolve its shadow. So we wrote this paper where we made predictions about
more easily than we can the black hole in our own galaxy.
Yeah, both of them occupy roughly the same angle on the sky, which is tiny, by the way. We're basically using, we correlate the data that is obtained from stations across the globe. And from that, we basically use the entire Earth as an aperture and can resolve the tiny size of the shadow of the black hole. So about 15 years ago, we wrote a series of theoretical papers with my postdoc predicting how the image would look like. And by the way, it was quite rewarding to see it on the cover of the New York Times, the Wall Street Journal.
Everything. All over the world.
All over the world. Something that was just theoretical a decade ago, appearing for real. And there are two ways by which you can analyze such an image and learn something new. First, it could have been that Einstein was wrong, that gravity is not really behaving the way his equations prescribe a black hole to look like. And it seems that the equations work fine, that the predicted shape of the black hole shadow resembles what we see. The second thing that you can learn is how matter behaves under extreme conditions in the vicinity of a black hole, where, once you cross the so-called horizon, which is a region around the black hole, once you enter into it, you can never check out, which is an amazing concept if you think about it, because a black hole is just a distortion of space and time. There is nothing there. You can cross the horizon of this M87 black hole and you wouldn't even notice. Nothing will happen to your body. It's just that your friend, who might be outside the horizon, would not be able to receive any signals from you. It's the ultimate prison. Even light cannot escape from that region. You can cross the horizon without feeling anything, but then eventually you reach the so-called singularity in the middle, where you will be torn apart by the very extreme gravitational tidal force.
But the gravitational pull at the horizon is something that in principle would not destroy all that.
No, if the black hole is big enough. These objects that are extremely massive, these beasts, black holes that exist very early in the universe, by the way, we find them when the universe was only 5% of its present age. It's sort of like looking at a nursery and finding a giant baby already early on. We find such black holes up to billions of solar masses early in the universe, and they are very rarefied. So you can cross the horizon of those without noticing anything unusual. On the other hand, a star that is approaching the black hole at the center of the Milky Way galaxy would get spaghetti size. It will get stretched into a stream of gas that destroys it, basically. And we see such events every 100,000 years.
And so when we see all of that light that is around the black hole in the photos, is that the debris of stars that are being distorted by the black hole itself?
It could be most likely just gas that fell towards that drain, that sink from the host galaxy. So the way to think of it is just like water going down the bathtub, and there is a reservoir of gas in the host galaxy that slowly drifts inwards and accretes onto the black hole, and that's how the black hole grows in mass.
Now, I have to say, when I first saw the reporting on you in your response to this object, Oumuamua, I was a little surprised that everyone was surprised that you were saying this, because, I mean, it seemed like an unexplained object deserves to have speculation, right? That's what science is all about. But you've taken a fair amount of heat from many in the field who seem to argue that this is not acceptable approach to science. Now, I mean, I figure because you're here at Harvard, you have tenure, you run the center, some clearly disagree. But what's it like for you in the field right now as an academic? How do you think about the way your discipline functions on these great unknowns?
Well, first of all, I should say that the people I respect scientifically were very supportive. There was a small minority of people that I do not particularly respect that were vocal about it. It's very unfortunate because if we look at the history of science, the progress was always based on independent thought and on evidence, not so much on social pressure. And what I see is people objecting to the notion of an extraterrestrial civilization as part of the mainstream of astronomy, while at the same time, in theoretical physics, people contemplate the notion of extra dimensions for which we have no evidence.
String theory.
String theory. It simply helps some theories unify two pillars of modern physics, quantum mechanics and gravity, through the mathematics of extra dimensions. But that doesn't mean that extra dimensions exist. If you just look at the evidence, we have 3 dimensions of space and 1 dimension of time. And if you were conservative, you would basically say, let's unify those theories within what we know. Nevertheless, people are allowing themselves to explore the hypothesis that there are extra dimensions, and it's becoming very popular. There is a whole community of people doing that. And that, to me, is a paradox, while at the same time, if I say that on many other planets, a quarter of all the stars have a planet similar to the Earth, and if the conditions on it are similar to those on Earth, you might get the same outcome. People have a taboo on discussing it. I find that unhealthy, because I think that we should put all possibilities on the table and explore the evidence. The problem with having a prejudice and gut feeling is basically that it assumes that the future will be the same as the past, and it doesn't rely on evidence. And I think we should not have a prejudice simply based on the history of science. For example, just to give an example,
Sure.
In 1952, there was an astronomer that said, let's imagine the solar system being arranged a little differently. Let's imagine taking Jupiter and putting it closer to the sun. And if that's the case, then it would move the sun back and forth as it moves around the sun, and we might be able to detect the existence of such a planet much more easily. And so let's search for close-in Jupiters around other stars. For 40 years, time allocation committees on major telescopes refused to give time to observers to look for such systems. Mm-hmm. Why? Because we know about Jupiter being far from the sun in the solar system, and we have a theoretical understanding of why this is the case. 40 years later, some astronomers dared to look and found the first exoplanet, which was Jupiter close to a star. It opened a new field of this study of exoplanets. And since then, thousands of planets were discovered. If you think that you know the truth before having evidence for it, you are misleading yourself.
So what's the research area in your field right now that excites you most? What's the one that you think is most fertile for a world view, a philosophical changing conclusion?
I think it's the search for extraterrestrial life.
You do.
Either in the form of microbial life or in the form of technological signatures that we might find out there. It would have a fundamental effect on society. It will change our perspective about our place in the universe. It could introduce new areas of research, for example, how to communicate with another civilization, astrolinguistics, how to trade with other civilizations, how to learn from their technology. Should we ask them for answers to questions that bother us? We can learn much more than we can teach in that process.
If you're willing to power your lights with dead dinosaurs, you should be willing to borrow technology from extraterrestrials. I mean, neither of which have anything to do with us, right?
I agree. Most people focus on the two-dimensional surface that we have here on Earth, worry about mundane issues like borders, disputes about financial matters, Brexit. These are, when you look at the big picture, these are childish issues. We really have to think bigger than that because in the long term, we will be forced to think bigger than that.
I mean, Brexit is stupid even in the context of the short term, right? I mean, that's just an enormous waste of time. But generally speaking, I see where you're going with this.
And the way I see science is as a continuation of our childhood curiosity. I remember my childhood as being very enjoyable, growing up on a farm, and basically thinking about the big questions and not being afraid of making mistakes and just being curious. And when I watch people around me, as I entered academia, I noticed that this innocence, this fundamental curiosity is being lost. You have to play to the tunes of selection committees. You have to look distinguished. You have to look nice in the mirror.
I know, but tenure means never having to look distinguished.
Exactly. So, in fact, that's the paradox. Yeah. You would expect tenure, which was formulated in order to give academic freedom to scholars, you would expect people to behave in a more risky way, taking innovative ideas and pushing them in order to find the truth. I mean, you never know in advance. You have to take some risks, as you do in the context of business. And the strange thing is the business world adapted to that. There are venture capitalists funding a lot of risky projects because they know that one of them might mature one day and pay for all the rest, all the failures. And for some reasons, academia became much more sterile. And the issue I see is that it also leads the public to some kind of to develop a distance from academia. In the populist movements, academia is viewed as the elite. And I see that as a self-inflicted wound. I see that because I notice my colleagues saying, let's find out the truth in a closed room, figure out the final answer, and then come out to the press or to the public when we know for sure what the answer is. To me, that sounds arrogant. The public should see that most of the scientific process involves uncertainty, where we don't have enough evidence, we're trying to find the truth. Once we converge with a unified opinion, it means that the evidence is beyond a reasonable doubt.
You don't want it to be magic.
No, I want it to be transparent and straightforward. And in fact, when people come to help me at home, for example, when we had the problem where the basement was flooded and because the sewer was clogged by roots from the nearby trees, it occurred to me that we don't often think about what happens to matter as it falls into a black hole. Just the same way that I didn't think about where the water goes when it leaves my house. It goes to a reservoir of the town. But I've never thought about that until the sewer was clogged.
Sure.
So that led me to think, where does matter actually collect in the inside of a black hole? And I thought maybe there is an object there, a quantum object, where all the matter that falls in, 6.5 billion solar masses that made the M87 black hole must collect somewhere. And as a result of the sewer at my home being clogged, I started thinking about it. Maybe there is a quantum object at the maximum density that we can imagine, where all the matter assembles. Or maybe it goes somewhere else, to another universe. Or it's really a fundamental question that we cannot answer at the moment because we don't have a quantum theory of gravity.
Or maybe your drain pipe is an event horizon. And you just shouldn't put your hand beyond that. I mean, that's the other possibility. Avi Loeb, thank you very much.
My pleasure.
That's our show this week. We'll be right back here next week, same place, same time, unless you're watching on social media, in which case it's wherever you happen to be. Don't miss it. In the meantime, check us out at GZEROmedia.com.
The GZERO World is brought to you by our founding sponsor, First Republic. First Republic, a private bank and wealth management company. Imagine a bank without teller lines, where your banker knows your name and its most prized currency is extraordinary client service. Hear directly from First Republic's clients by visiting firstrepublic.com.
You're listening to the GZERO World with Ian Bremmer podcast, your weekly geopolitical deep dive into the world's biggest news stories, featuring in-depth conversations with global leaders and newsmakers. To get more of GZERO's insights on global politics every morning, sign up for our free newsletter, GZERO Daily, at gzeromedia.com.